Hello, this is Alex from cables.gl, and today I'm joined by Alex, aka AMajesticSeaFlapFlap, who
Hey there.
you might know as the creator and the mastermind behind some of the cool new operators we've been seeing in the last updates in cables.gl, especially the PBR Materials and PBR Environment map lighting, texture-based lighting for the PBR material. And in the last update, you made some more additions to the operator. And we're going to try to talk about them all. And hopefully it's not going to take a while, but I am in your example gallery right now. And you made this with the last update and used a bunch of your new operators as well. And I want to ask you, how are you able to come up with this stuff, first of all? Like, is this something you do for work, or is this something you are like passionate about to do physically based rendering in WebGL or maybe even on other engines? Because yeah, this stuff is really great and it runs quite smoothly, I think, and quite performative. And I'm super happy that you've made this stuff, and yeah, super glad that we can chat about all the new features, and I can pick your brain about like how do you come up with all this stuff.
Yeah, right. So this room was pretty much created as a test case because I was like, I want to show my patches, maybe like in a little gallery thingy. And then I realized that there were some features missing still from the PBR material that you need to create like a realistic-ish looking environment. So this was the main motivation behind adding those features.
And I guess that must have been sort of inspired by the fact that there was like new physics engine rewrite coming and some sort of collision, and you could actually like walk around rooms, or I assume that's how you came up with like, oh no, we need parallax map correction for the reflections or something.
Yeah, definitely. Like as soon as you start playing around with the example patches for the ammo stuff, you realize that, yeah, this is kind of cool and you can build on top of that. So that's definitely an inspiration for this one.
Yeah, I really like, I think it kind of keeps happening where we're all getting inspired by little breakthroughs and pushing our own like I wouldn't say agendas, but like it's our own like favorite parts about all this graphics rendering biz stuff on the web. But all right, so I like the artworks and everything in here. You haven't published this patch yet. I don't know why. It's awesome. I hope people can see that it's actually not that difficult to create this stuff. I think I assume you're quite well versed in Blender. I mean, I know you are, obviously. So, can you tell me like how much of a leap is it to go from Blender, if you're more or less comfortable enough in Blender to do baking or maybe creation of PBR materials in Blender? Like, what's the jump to doing it in WebGL? Like, is there a lot of things you need? Are there a lot of gotchas or what?
I mean, if you're used to baking workflows in Blender, you probably know how to bake diffuse lighting into a texture map, and this can pretty much be used one-to-one in cables now. So you would create your lighting setup and your environment in general in Blender, bake out the textures, and then take over the mesh into WebGL and use the new PBR features to get the lighting properly.
And when you create the operators, I assume you're also creating them for yourself, right? So it's based on a bit of the Blender workflow and like the way maybe other engines work, like Unity and things like that. Like, I guess that's where you see the AORM maps the most nowadays, maybe.
Yeah.
Yeah. So it's nice to get those workflows like under my belt as well, because yeah, it becomes quite smooth, I think, if you get versed in Blender, or if maybe like the fact that you can do something in cables pushes you to do it in Blender as well, and then you can have this nice tool pipe. All right. Well, I think I'm just like rambling now, but let's talk about specifically what's new in since the last update. Like, what have you added to PBR environment map and materials? And I want to start with something that jumped out at me like right away was this parallax correction. And we had PBR since the previous release, the one before the last one. And I always thought, okay, this looks quite good already, right? So I have this vase. It's from a past tutorial you guys might know where I did the AORM map workflow. But even I think then when I did that video, I didn't fully understand how to use the parallax correction yet. I think it was on the developer version of cables.gl. By the way, if you guys don't know, dev.cables.gl is the secret place where all the ops get birthed, and you can test them out and write issues and suggestions and stuff like that. But yeah, anyway, so what happens is if you have the helpers turned on and you press parallax map correction, you get this box. And can you tell me, like, this is I think quite a unique feature, I think, in an operator. I haven't seen it before. And like, how does it work and what is it supposed to do?
Yeah, right. So if you have a normal reflection going on, like without the parallax correction, it's pretty much only using the direction of the surface normal to do a lookup into the texture that we use. So this also implies that the reflection is pretty much like on a sphere that's infinitely far away. What you usually want to have, though, if you want to have like more depth in the reflections, is to use a projection, for instance, on a cube. And this is all that this does pretty much. Like it assumes the reflection to have been created on a cube, and this cube is also displayed there with a bounding box.
So I can kind of visualize these faces of the cube are projecting textures onto, it's like a cubic projection onto the reflection effect or the shader of this.
You can think about this like if you have rendered out, for instance, a square room, then this would fit the room perfectly. Like this would be have to be put like right like against the wall and against the ceiling, and then you have a more correct reflection.
So I should use this cubic bounding box to pretty much approximate, it's maybe a little bit difficult because here I have a skybox with a big room, so I kind of have to fake it a bit. But you basically use the bounds of your space of what the environment is supposed to be, not to try to like put your object into this cube, which is almost what is happening here by default. All right, so
kind of like you would have to put your object into the cube if you don't want clipping issues. Like if you go with a camera against the ceiling, for instance, it would just extend it. And also, if you're wondering what the third gizmo is, because like the two gizmos there are pretty much the information that you need for the bounding box, and the third gizmo is the center of the projection. So this would correspond to, for instance, the camera height in your 3D application that you use to create this environment texture.
I see. So okay, well let's set it up correctly because this vase is looking a bit sad now. So initially, I guess I would start with the center. So you can see that I'm already having some different effect onto the vase, and we're already getting some sort of reflection. Whoops. Spoilers. Okay, so then when I adjust the handle that controls the height of the room, I can also see this this kind of distortion.
Yeah, you're seeing kind of like a clipping issue as well. Like in this phase, you should usually, if you have a room or something, get the camera inside the cube, because if you are at the border of this one, then it will just clip upwards pretty much. But yeah.
Yeah, so now it's already starting to look quite good. And do you what's your advice about like keeping the shape of the room? For example, if my room, let's say, is cubic, it's probably not a good idea for me to keep this not cubic here because it's kind of like rectangular. Like, is it good practice?
I mean, it should always like be used to line up reflection. So if you have a non-square room and you have, for instance, like a window in the corner of the room and you want to line it up perfectly in the floor reflection, for instance, then you should try and tweak this to a point where you think that it looks kind of physically plausible, I would say.
So don't rely 100% on these handles,
Yes.
but mostly try to just match up.
I mean, the handles are useful if you have like an exact 3D room, like if you want to just render out a room and create like a little gallery thing, for instance. Then you can use the exact values, but it should still be like, if it looks right, then it probably is. So
I'm even thinking like if I want to squeeze in highlights somewhere, I can just totally cheat and like move it into place, and maybe it will look even better than trying to just match the boundings. Okay,
what you should always keep in mind, though, is that the object position also matters. So, for instance, if you have an animated ball or something rolling around in one of those reflection cubes, then the reflection will change. It will not do that if you don't have parallax correction on, but it will if you have.
Let's try this actually.
Yeah, so you can see the reflection is moving along.
Right, so you get, it's a much more believable effect. And if I, again, turn off this correction, the difference is quite drastic. And I think to my brain, like, it does look better, like, when you use it.
Yeah, I mean, it does have depth, and it doesn't have before. And also, if you're used to engines like Unity or Unreal, where you have like reflection cubes, this is pretty much exactly the same thing, like from a implementation standpoint.
Yeah, I guess I don't want to skip ahead, but definitely when you're dealing with things like already walkable spaces and galleries, right? Like it gets quite tricky to keep the reflections correct if for example there's a hallway and a door that leads to another room, right, and this ball rolls from here to there, but I think there's still like cool tricks you can do, and maybe even fade those things. I don't know, there's definitely no limits to the creative ways you can solve that issue, but I would definitely like I definitely think about it now that I have this effect in the toolbox. Like, you just want to keep everything looking awesome all the time. So like when you traverse into different rooms, or you're making a game or something like that, you might hit this kind of conundrum. But I really want to try it, and I hope someone else tries it, like to just show what you can do with multiple reflections like this, or multiple environments, how to like fade them, or maybe cheat in some way. And
also something that you see in this example, like very well in this example, is like one of the smaller tweaks that you probably won't like change for an object, which is the multi-scattering. So the approximation of rough surfaces got a lot better with this update as well. So the color of the vase is also a lot more accurate.
Yeah, definitely. I remember opening some older patches, and there's definitely has been a much improved color treatment to these materials. And I guess we can jump right into that actually, because you can do way more with the colors now. You can get into tone mapping, which is now we're moving on to the PBR material. It's a section inside the parameters that allows you to get into a couple of different modes. And there's also an exposure control. And can you tell me, like, what's the usual workflow for you? Like, if how do you decide like what's best to use?
Yeah, right. So the tone mapping itself is just pretty much like, if you have the result of the old PBR material, it was pretty much only like the result of a calculation and not really color values. And what the tone mapping does is it remaps it to a range that is actually like more pleasing to the eye. For instance, like approximating a photographic sensor or using a different kind of approximation. What this means in practice is that you can use it to get rid of the weird tonal range that you have. Like, for instance, if you just put it on sRGB, you see you clip very fast. Like, you have a lot of clipping going on in the highlights. And this is usually something that you do not want. So you would usually use like another one of those tone mapping operators. Those are, by the way, from Babylon.js. If you people are used to it, then it's the same thing, pretty much.
Nice.
And then you would go in and get the dynamic range back by, for instance, doing something like contrast or saturation in post to get the effect that you like.
Yeah, so this is I'm not like a total colorist guru or anything, but playing around with DaVinci and F-Log and all that Fujifilm stuff definitely reminds me a little bit of this. I'm like, wait, this is like subdued colors. Should I be doing some color correction in post now, like on these materials? And I guess that's the idea, right?
Yeah, the idea is to have like a more cleaned up pipeline where you actually have something that you can use as a result, and then use like a lookup table or other like image compose operators to get the look that you like.
Yeah, I feel like there's some movement behind the scenes at the skunk labs of cables with better treatment of colors and tone mapping and post-processing color correction stuff. But that's for another day. All right, so that's really nice. I love that you can adjust the settings a bit more now, like in a more interesting way, instead of going directly into post-processing stuff. You got some controls in the material now, so that's great. And now moving on, there's another thing we wanted to talk about, which is this use roughness from normals. I think is new, correct?
Yeah, true.
Yeah.
Like this is trying to solve an issue where you have like high density normals. So in cables right now, you have in the PBR shader two options to get rid of too dense normals, pretty much. Like the first thing is geometric roughness, which is roughness based on geometric density. So if you have a very geometrically dense object, then you get more roughness, basically.
Mm-hmm.
But this might be something that you don't want. Like if you, for instance, have a car or something and you get way too much roughness in there, then you can disable it there with a checkbox. And what the next one does, the roughness from normal map, is also a screen space approximation of roughness resulting from high density normals. So what this helps with is specular aliasing, pretty much. Like if you know, like you have very dense normals, then it's very probable that you have like a lot of samples going in different directions for each pixel.
And you get like these little brightness spots. It's a terrible model to show this, but if you zoom in, if you screenshot this video and zoom in and then cycle through, you might notice the difference. But yeah, it's quite clear that it tries to solve this spotting issues.
Yeah, I mean, this is also a very rough approximation. Like you would usually want to do something like Toxvic or something, or even lean mapping, but that's not really feasible for real time. So yeah, this might also be something that would change in the future, but this for now is like a nice way to get rid of aliasing that you have due to normal maps.
Yeah, I think I remember we were working on like a chainmail, like a knight or something with chainmail.
Yeah.
I definitely recommend anyone with super complex material or geometry, and they're using PBR materials to pay attention to these two new options to maybe solve some of those issues. Yeah, that's really cool. And then quite an interesting addition is the usage of vertex colors in PBR material is also new.
Yeah, so now you can actually use vertex color channels as inputs for the PBR material and like choose what you want. For instance, if you have a high density mesh from like a CAD software, for instance, then you could use the vertex color channel for something like ambient occlusion and save a lot of texture memory by just dumping it all into the vertex colors.
Yeah, that's quite interesting. I think whenever we talk about vertex colors, I always say the same thing, which is I think they're underused. So it's pretty awesome to see. The fact that you can use red or like RGB vertex colors to control the AO reflection and metalness of a model. And in practice, I guess you could actually save quite a lot of memory and
Yeah.
file size.
And also something that is kind of like ignored here is that you could also, in theory, have more than one vertex color channel. For instance, like one for the AO, one for the lightmap and stuff. But that's stuff that might be coming in the future.
Yeah, true. I think it's on dev.cables.gl if anyone's interested. I think we now support multiple colors. But anyway, that will probably help evolve PBR material. I guess that's this like feature tennis that we talk about, where it's like, hey, that would be cool, and then someone else like Pander adds it to another operator, and then it allows us to play around or to develop operators that use that feature. Wow, what is this? Go away. So then height map. Well, let's leave this vase finally and move over to the height map. So I already did a tutorial about this, but it's a lot different when I can ask the creator of this stuff actually how it works. So to me, it's still quite magic. I see the word parallax, and I'm amazed immediately. But tell me what is actually happening, because I understand you take a luminosity map like black and white texture and you put it into your PBR material, and then magically you can start to use the height map intensity like so. But
yeah, right. So first of all, I'd like to take a huge shout out to Jasper Flick for his tutorials, because it's pretty much like following along to that. And what it does, it translates the camera view into the tangent space of the surface, and then does some ray marching based on the depth map that you get with the displacement map.
Nice. Yeah, that's really cool. It's actually it's not that expensive on the processor or the graphics card, I think.
Yeah, relatively. Like the most expensive part about this is pretty much transforming the camera into the tangent space. This is like one, like not the most, but one of the most expensive ones, which is also why there's an option to choose for faster height mapping.
Yes.
Because information can be done per pixel and it can be done per vertex. So what I do by default is do it per pixel, because this results in like a lot more accurate result with stuff like planes that are bigger than the camera. Like if you zoom in a little bit and change to faster height mapping, you see the difference. Like this is right now calculating it per fragment or per pixel on screen space. And if you enable faster height mapping, you see the look changes.
The look changes for this one, yes.
Yeah.
But not for the background.
And this is due to like the interpolation, because you have like one huge triangle on the right side, and the thing in the background is a lot more dense because you have a cylinder. So the effect is a lot more subtle, like the artifacts that you get by interpolating instead of calculating it per pixel. So this means, from a practical point of view, if you have a huge like floor, for instance, and you have like nice little height map details in there, don't check faster height mapping. And if you have more dense geometry where you know, okay, I have triangles that are in screen space and a lot smaller than you would usually have them in like this example, then use faster height mapping.
And the cool thing is you can do this at runtime, which is great. So you can actually, I mean, if you really get into it, you could definitely like test how far the viewer is, and then the closer they get to whatever has height map, maybe it can flip on. Like at certain distances, you can hardly notice the difference. So actually, you can do it quite seamlessly.
Yeah, it's all like an
on, and then it's like, wow,
interpolation thing. So you can also use it to just load your mesh in and click it a bunch of times and see like, okay, does it make a difference? No, yes. And if it doesn't, just use fast height mapping.
I see. And I would, getting more in depth, with this stuff, like the field of view seems to matter quite a bit as well.
Yeah, kind of, but like this is to expect. Like most implementations of the of height mapping actually have this kind of artifact. So you get like, if you use very high intensity height maps, then you get like a little bulging in the middle, pretty much. So just keep that in mind. If you like overdo it, then you will get some artifacts.
Well, my favorite thing is to overdo it for sure, because you can make some crazy materials. I think that's always the best, is when you come up with an operator that is both realistic and artistic at the same time. Like that's so fun to be able to be like, okay, these bricks are cool, but what if I put in some plasma or um, diffused whatever water waves into there or something like that and see what happens.
Yeah, and also like nothing is limited. Like intentionally, none of the parameters are like limited to positive values or something like that. Like you can go absolutely crazy if you want to.
And when you create operators, like do you keep that in mind that like, okay, this height map intensity, you know, at extremes doesn't make any sense maybe, but I'm gonna leave it in anyway because you never know.
I mean, I think one of the basic ideas behind PBR is to get like physically based rendering is to keep the parameters understandable and if you can in the range between 0 and 1. So this is also something that I try to aim for with those parameters. So you have like logical 0 to 1 values that make sense. Like, I mean, this kind of makes sense, right? If you put it to 1, then you get like a certain set depth.
Yeah.
But I also find it very important to keep it open. Like if someone wants to do something with negative exposure and negative light sources or something, like why not? Why keep the artist from doing that, right?
Man, how could we, like that was the one of the coolest features that you added for me was the fact that we don't need the environment anymore. We can actually use cables lights. How could I forget? Yeah, so this exists now. I don't know if this is the best patch to show it with, but
yeah, this is also like a huge shout out to Filament guys, like the Google WebGL engine, because this is pretty much like taken from them because they have a very permissive license. So you get like nice, very physically based light sources with the default Phong operators. So if you're used to working with directional light or point light or something in cables, then you can also just continue doing that. The parameters are a little bit different. Like for instance, the radius isn't used for like the distance, but rather for the light source radius and things like that. So you might have to play around with it a little bit, but yeah, I try to keep it as like bare bones as possible.
I'm just gonna place down a sphere and see what happens.
Yay.
Yeah, it's a sphere. Okay, so this is now not using any image-based lighting, so we just have
should
a
probably
point
make
light
the sphere smaller, right?
and
The sphere is probably too big.
yeah, it's probably covering everything.
Ah, there we go.
It's back. Yeah, so the way you've implemented how PBR Material understands the lights is, I guess, closer to how it works in Blender or Unity, or because I guess I would think, okay, if you're making the light giant and it has an intensity, like it's going to be an intense giant light. But in reality, like your intensity gets spread out, right, over the size of the sphere. So it becomes actually weaker as a light source to the object you're working with.
Yeah, this is all like one of the principles behind like physically based light sources, where you try and mimic reality. So if you have the same intensity over like a bigger sphere or something, then it will always have like a smaller intensity per surface area patch, pretty much.
So I think that's important to keep in mind when people will. Well, I hope our listeners will try out this new workflow with cables, lights, and PBR material. But remember to maybe make them a bit smaller or way more intense for the PBR material to work.
Yeah, it will require some tweaking, definitely, like if you have a scene that you used to. And also, this is one of the examples where the parameter limitation isn't applied, so you can use negative light sources if you feel like it, right?
Yeah, exactly. That's what you said earlier that made me remember. You can do really crazy, like almost light painting with different light sources and just stack them and get really wild effects. It takes some time to experiment, but I highly recommend it because it's pretty fun to mix super intense positive and negative lights. Yeah, you get interesting shapes, but yeah, that's for a special type of um, creative. All right, so I love this feature so much because it really brings PBR material into like you know, into traditional cables material world where you're like, yeah, I don't really have any image based things. I want animated dynamic lights, and in our um, June release room updates patch, you get this effect quite in a cool way because it starts to act like a reflection of the light itself, like as it animates around the at the source. I think it's really, yeah. Please, everyone, try it out. Don't be scared. It's super easy to set up. It's just like everything else in cables. You just throw it and try out the new physically based materials with the dynamic shadows or dynamic lights that can have dynamic shadows, which is cool. Okay, well, let's move on to something else now. Clear coat. What is clear coat?
So a clear coat is a thick dielectric layer on top of the like underlying material. And this was something that I wanted to implement for the floor in the gallery room that I created, because I noticed like the reflection looked very dull with just using the wood itself. So the clear coat was the next logical step. So
And
maybe something that is a little bit different to other implementations of clear coat. This isn't very energy conserving, so you don't really get the proper energy conservation for now, but that might change in the future. So just keep that in mind. Like if you use a clear coat with, for instance, like a low roughness, then you will have some like too much energy on the like grazing angles. But yeah, it can be used for stuff like car paint or this where you fake like a more complex object.
yeah, this is very interesting. I never actually looked at this without the clear coat, and it's a completely different effect because you are affecting this kind of bubbling surface only. But
Yeah,
you
this is
can,
also something that the clear coat can be used very well for. Like if you have a very complex surface behind glass, for instance,
yeah.
like in a room where you have something, I don't know, like a fire extinguisher or something behind a glass window, then you can use this to fake this effect pretty much. And
Oh,
just
that's
do
a
it
cool
all in
idea.
pictures.
Yeah, yeah, that's great. And I also think if I remember using this in my tutorial about the new features, and uh, this I think has a huge impact now with the parallax correction. Um,
Yeah,
it
true.
looks quite different without it, and it's pretty interesting to see. Parallax correction and clear coat like on the same material. It looks super wild. Like it's indeed behind like a glass layer. Yeah. So the cool thing about clear coat, it has its own control for the um, roughness, so it can be very shiny or dull. So you could, yeah, indeed. I want to try that actually. That's a good idea. Like a jar of pickles or something, or like yeah, something, some specimens in jars. That would look cool. Mm, okay, well, I'm gonna let the next patch guide me because I'm kind of, I think we're reaching most of the features now. Ah, yes, of course, most important new feature that I had a lot of experience with. So this is the template room that you'll find with included in the templates for cables now. When you create a new patch from the drop down in the menu, and you'll see that it has a blank look to it, right? Like it's there's no textures. It's a totally blank room, but there is some sort of an effect of as if there's light coming from somewhere, and there's some shadows here and there, and these lamps are casting lights, but this is all obviously fake. but it's fake in a good way because CFlap added light map support to PBR material. And this is actually quite interesting. And you'll find it all the way at the bottom of the PBR material parameters. And tell me, like, how does it act with other texture maps and everything that would plug into PBR material? Because I guess that's really like the goal of PBR material, for you to have more control over this kind of light and shadow effect on your material. Because, if from first glance, this just kind of looks like what we are used to seeing on the web, which is completely baked out textures that are without any kind of dynamicity or dynamicism to the way they work. And this isn't really the case with the way light maps are in this PBR material that you made.
All right, so if you have the environment light without any like light mapping and stuff like that, you pretty much have the same situation like with a specular map, where you have the same like lookup just based on the normal, just varying with the normal. And typically you want more detail in there. Like for instance, if you have a room, you know that like the diffuse lookup from the center of one of those walls would be very different to one of them like in the corner. As you can see, like there's some darker spots and there's some lighter spots.
Mm-hmm.
So what those light maps do is pretty much replace all the diffuse information in the environment light with the information that is baked into the map. So if you bake, for instance, in Blender, a diffuse channel without a color, then you get the result that you can directly use in cables.
And to me, like, because I'm quite new to this, if you can't tell, like the AO map is different from a light map, because a light map is also kind of going in the other direction of not just having shadows, which I guess is what occlusion is for the way light loses power, but here you also have the brightness of like a lamp next to a wall or something like that. And like, are these two texture maps close, or are they, why do we have both now? Like, is there a reason to have light map and AO in one material?
Ambient occlusion isn't really physically based, right? I mean, ambient occlusion is just a way to approximate diffuse lighting around like an object, so you get more detailed lighting that you wouldn't have otherwise, because you only have a lookup, right?
Mm-hmm.
So if you bake diffuse lighting in Blender, then you by default do not have any ambient occlusion in there. It's just the ray tracing information. And if you want to have some like more contrasty lighting on top of that, you can use an ambient occlusion map on top of that. But keep in mind that this is like ambient occlusion is always fake. This isn't the thing.
Right. It doesn't consider, okay, you have a lamp there, so there will be less shadow somewhere else. It's just looking at, I guess, at angles of the room.
Yeah, it depends on how it's implemented, but yeah, along those lines.
Okay, well, the coolest thing I think is that you can have way more control of how your scene looks, to keep it simple.
Yeah.
And there is this light map intensity control. So I think you could even simulate like lights being turned off or turned on, or like the time of day changing in the same space. I think that's quite a huge leap, I think, for PBR material. And what is the format that like do you recommend to use for this texture map for this? Because I guess they need to be like a linear format or 32-bit float or something like that.
Yeah, so this is actually probably using the XR textures that are like a new feature in the second to last update, I think. So you can just use like XRs natively in cables if you want to, but always keep in mind that those can be quite big. Like if you have a large XR file, then it can be a lot bigger than you want to. And then you also always have the option in cables to also use RGB encoding to maybe save some space.
Right. And this toggle here is for if you're using RGB encoded textures. Right. Or I think here I am basically just using RGB to float 32 to then have a really tiny file and then turn it into a cables image compose that I can
Yeah, so
then
this
play
this
around
workaround
with.
is quite nice to get rid of some artifacts that RGB textures have. You can use this setup to get rid of, for instance, like a little bit of banding or boxing that you may be getting if you use the RGB option.
Mm-hmm. Yeah, this operator is quite cool. RGB to float 32, so you can have really tiny RGBEs, and then it's 512 pixels.
Yeah, maybe also on this note, these light maps are always using the second UV channel. So the object that is being used should have two UV channels, even if they're the same.
Right. That's another thing. Not only are we getting into multiple vertex color channels that we can use for different things, and in the future probably at the same time, but we also have multiple UVs that you can, allows you to have more flexibility in the way you texture your models, where you might require way higher resolution and somewhere else maybe lower resolution. But for the light map, you might want to keep it completely even or have a completely different approach there. So for example, let's say here where the light falls in through this hole here, I definitely need more information for the light map, so it's not splotchy and ugly looking. But maybe for texture wise, I don't really need this area because there's not going to be any wallpaper here, or there's nothing like unique happening. I just want it white or something like that. So multiple
Just maybe like a
UVs.
small tip on this note: if you use Blender to create your models, keep in mind that the GLTF exporter from Blender will always use the tangent space from the selected UV channel when exporting. So if you have a mesh that you want to light map and also use height mapping or normal mapping on, make sure to select the first UV channel or whatever UV channel you want to use for the normal mapping.
True that. I don't know if we should probably make an issue about that for
Maybe.
for the GLTF exporter, because we're huge fans of the GLTF exporter. If anyone is listening from from that team, huge thank you. But yeah, that would be a nice thing to catch and avoid in the future, because it's kind of strange that it matters which UV you select when you're working with multiples. Because PBR material highly shines when your GLTF scenes have proper tangents exported in Blender, which is by default off in the GLTF exporter.
Yeah, like there's a lot of small issues that you can fall into when using the PBR material. So also feel free to ask questions on Discord if
Yeah,
you run into any issue.
come by, talk about what's in the works for the future of PBR material. Show us what you're doing with all these sweet features. How long have we been talking for?
It's
Like
been a while.
45 minutes. Hopefully it was not too rambly, but I really enjoyed it. And yeah, I hope we do more of this. And again, huge thanks. It's an incredible operator, and I love what you're doing with Pander on this stuff.
Yeah, and also huge thanks to Filament, Babel.js, and Jasper Flick for the permissive code licenses that make this possible.
Yeah, huge shouts. Maybe we'll tag them and ask them to come watch our video. Thanks a lot, guys. See you on Discord. See you at the meetups. Make an account, make some patches, and thanks for joining me, Alex.
Yeah, no problem.
Talk soon. Bye.
Bye.